Hey, I'm Anand Kulkarni. I'm the CEO and founder of CoreStory. We started CoreStory to help bring enterprises into the AI era when it comes to software development. We all know about the power of large language models and understanding software creation. Everyone's had experience in using LLMs to build fun projects or brand new greenfield applications. But one thing that we saw consistently was that language models struggled when it came to doing real-world engineering tasks on large enterprise systems, the kinds of activities that senior engineers have to carry out every day. Even though language models are great at understanding small amounts of code, they quickly lose context when trying to understand how to carry out complicated activities of the kind that we might want to do as real engineers in real-world enterprise systems. CoreStory solves the problem of figuring out how to make coding agents work in real enterprise contexts. We reverse engineer large existing enterprise code bases back into requirements and specifications, allowing an approach we call spec-driven development. Coding agents can consult the spec that we create as an intelligence model, consulting it and using it as an atlas to understand where to make changes on a code base. The end result is that teams are able to use artificial intelligence to maintain and enhance existing enterprise systems.
So how do you see the relationship between human developers and AI agents evolving over the next, 3 or 5 years?
So we all know we're in a sea change in how human beings build software. And it's not the first sea change that we've seen as an industry. This kind of thing happens every 40 years or so, where everyone gets to come up with new ways to build software. I think one of the mistakes people make when they think about what AI can do inside software engineering orgs is thinking that AI replaces the software developer. I think what it really does is change the job that a software engineer has. Whereas before, software engineering teams really were about figuring out the plans to coordinate teams of human beings and working together, and understanding how they can build software systems by individually writing code and verifying that it works. Today, in the AI era, software engineers' jobs change to think about how to solve problems effectively and to think about how to enable teams of AI agents to do their best work. The gains from doing this kind of transformation are really profound for most organizations. We've seen from teams who are implementing spec-driven development or AI native engineering using CoreStory inside their own engineering organizations, they're able to achieve 200% velocity boosts or better in their ability to carry out day-to-day engineering tasks, a remarkable shift that's really only possible in the AI era.
So AI coding agents are pretty cool, but why do you think they're having such a slow adoption? Why are they struggling with some of these enterprise code bases in ways that we don't see with typical vibe coding or greenfield projects?
So coding agents struggle inside large legacy code bases for three big reasons. The first is that enterprise code bases are too large to fit effectively into the context window of most LLMs. If you think about where even today's best foundation models cap out, it's really around something like 200,000 to 1 million tokens. Translated into code, that's really just 50,000 to 100,000 lines of code. Not a lot of software systems that we work with are that small. In reality, we have software systems that are written with spaghetti code, with complex interdependencies, sometimes with black boxes, spanning multiple languages that might be outside the training sets of existing language models, or systems that require insights into how software platforms are structured. These are difficult for language models to understand consistently when they think about how to understand what is going on inside a code base. We've often had this experience, if you've tried working with any of the popular coding agents on a substantive software system, that it can do really low-level, simple tasks that are small, somewhat effectively, but they struggle when they come to carrying out real complicated tasks that we might want a human being to carry out. Understanding how to get that right is one of the key reasons that CoreStory exists. When we work with organizations to implement AI native engineering, we help them build out enough context with specifications and with the intelligence models we provide to allow them to get their AI agents and their human teams to work effectively.
So there are a lot of different code analysis and security analysis tools out there in the market. How is CoreStory different from what you see from whether that's a code gen or any of these code analysis tools? What is code intelligence as you define it?
So code intelligence is really emerging as a distinct category of software product compared to coding agents or systems that let you scan through code to analyze it. I think about this as the relationship between a product manager and a business analyst and a human software developer inside a human organization. Software agents are great at generating software from small specifications and well-defined instructions. They often require some kind of deeper understanding of an existing software platform or clearer instructions about what to carry out in the same way human beings do when encountering a large code base for the first time. Code intelligence models like CoreStory allow software agents to understand the actual functionality of a software platform in relation to the actual language that human beings use to describe it. That's often the same language that customer feature requests come in, that maintenance requests show up in, or that tickets inside a development backlog show up in. Those are places where intelligence models allow coding agents to get a lot smarter in carrying out tasks. They can look at the specification generated by the intelligence model. They can ask questions about how to implement a specific set of tasks. And then they can generate highly accurate pull requests or solutions by consulting the existing spec that's contained within the intelligence model. That's substantively different from how coding agents by default try to figure out code bases, which often relies on code indices or search, places that don't really work well when we're thinking about how to make coding agents carry out the most difficult tasks. And this isn't theoretical, of course. We've shown this both with our own performance on major software engineering benchmarks like SWE-bench. It also comes up very immediately when we deploy out with customers to show how they can actually implement solutions like CoreStory to carry out meaningful increases in their own sprint velocities and day-to-day engineering tasks.
So how do they do it? How do folks typically integrate CoreStory into their development life cycles? Where in the process does it provide the most value?
So the key to understanding how to implement CoreStory as part of a spec-driven development model or an AI native engineering practice is really about setting up places where CoreStory can support one or more existing coding agents that are being set up in the process. Those are sometimes coding agents like Claude Code, like Factory's Droid, like Cognition's Devon, or like GitHub Copilot, and providing those tools an easy way to answer questions. There's really only two basic steps. The first is that you ingest your code base into CoreStory to create an intelligence model, and the second is you turn on the MCP server integration to let your coding agents talk to CoreStory's intelligence model. And that's it. Teams that end up implementing using this approach can start to see velocity gains almost immediately because the agents they are setting up are able to carry out more complicated engineering tasks more quickly and more effectively than before. Of course, the bigger part of the challenge is sometimes understanding how to get the human organization to follow along with the processes and figure out what kinds of tasks are well suited for CoreStory and the coding agents, and which parts they want to make sure still have human oversight and human involvement. And those are great places where there can be a meaningful discussion that we often see customers like to engage with.
We have an obvious use case around modernization, about taking existing systems and being able to understand them and take action upon them. What advice would you give to an enterprise that has millions and millions of lines of legacy code? And what are some of the misconceptions that you've seen people have stumbled across when working with these large code bases?
A huge portion of the interest and excitement we see around CoreStory is the ability to use CoreStory to understand large amounts of legacy code. If you're a CIO in the enterprise, you're probably sitting on 1,000 to 2,000 production legacy systems that you have inherited that have been built up for 30, 40, 50 years, that are poorly maintained, undocumented, and where you are investing lots of IT budgets. This is often the single biggest sticking point that CIOs approach CoreStory to try to solve. There are three big ways that I encourage teams to think about their legacy systems in the AI era. The first is that I think they can move away from the historical false dichotomy of maintain versus modernize. Everyone hates this because they think, well, look, it's a sunk cost I'm going to have to live up to spend X million dollars and 5 years of modernization work to change my old code into new code. That's actually how we have always modernized our software platforms, is just by taking the time to document what it does thoroughly and then spending all the time, money, and incurring the risk of moving that system painfully into a new framework. That is really kicking the can down the road to the next CIO to modernize that same system, which is about to become legacy again in another 5 or 10 years. And most of those modernizations efforts fail somewhere along the line because of the high risk and the high complexity. In the AI era, there are some big things you can do differently that get you out of that dichotomy of maintain versus modernize. The big one is that once you've got coding agents in place, you can start to think about this as a AI maintenance problem as opposed to a replatforming problem. In other words, if your code is working, maybe the real issue isn't that you are trying to modernize it and move into a new framework. Maybe the issue is you just need to figure out how to efficiently maintain this thing without dragging out all of your budget. So that's the first big shift companies can think about. They can shift into a model using CoreStory and the AI LLM of choice. You can document every behavior of this code base automatically in a matter of hours using CoreStory. You can set up a team of agents to consult that intelligence model to effectively maintain the activities, the feature requests, the development needs that that system has, and you can substantially reduce the IT budget that you are spending on keeping that system up to date and working without the need to re-platform that system entirely. The second thing that you can do differently is you can choose not to modernize the whole thing as an all or nothing effort. Once you've got the system specified in full using CoreStory, you can choose to selectively move pieces of that into a framework of choice with high confidence and low risk. The key of having effective specifications is that you can generate clear acceptance criteria and accurate, reliable tests that describe every behavior of that software system in a way that allows you to move with confidence when you are shifting out parts of that code base into a new framework. The third big change you can make here, and this is the most important one, is going from a system that is undocumented and unspecified into one where you've got complete and accurate requirements for the whole thing. And that is a new kind of modernization that might mean that this is the last modernization project that a CIO needs to run. Once your system has a fully up-to-date spec that is kept up to date as the system changes continuously using CoreStory, you can now choose to treat that spec as the source of truth about how that software platform behaves. Instead of migrating every 5 years, you can just live with that spec and choose to transform it using your favorite coding agent into whatever language or system you need at a given moment. And that's a fundamentally different way for CIOs to think about their enterprise systems than as a collection of poorly maintained code the way we always have. I think that's going to be the way that we all look at our software platforms in the future, and certainly in the AI era, as a requirements layer that the business, that developer teams, and their LLMs can all work with together.
So the system of record, or the source of truth, is shifting away from the code base into a well-defined specification, if I understand, for what is the definition of software-driven development, or software-defined development. SDD is something that is relatively new. Where do you see it going, and why does it matter, and what does it mean for modern software teams?
Okay, so spec-driven development is the idea that in the AI era, the specification for a software system is the source of truth for how that software behaves, much more than the code, and that the code itself is something of an ephemeral artifact. Coding agents can generate more code at a cost that is almost zero. Therefore, the most important piece that we can control is that spec. Understanding how to make that spec reliable, complete, accurate, and consistently up to date with the behavior of the software system is really the most important part of how we think software agents will need to be governed in the AI era. If we look at what that actually means in practice, it means having complete, reliable, and accurate test coverage coming out of a spec. It means that agents are using that spec on a daily basis to update and change that code base. It means that organizations have figured out how to keep that spec living, attached to the code base, and perpetually a source of truth. So we are consistently hearing, seeing, and now supporting organizations that are trying to make those specs the source of truth for how they build software.
Where do you see the biggest opportunities are for enterprises that do invest in this type of code intelligence and SDD now?
So code intelligence gives you really big advantages in execution and in understanding what you've got. So many organizations are able to achieve material reductions in their overall IT spend. They're able to achieve much more in terms of velocity, time to market, project execution speeds, and in their ability to deliver features, components, and products that deliver value and ultimately revenue, because they're able to gain some of the advantages of velocity that you can get by following a spec-driven development practice. Organizations are able to substantially clear out their backlogs of maintenance tasks or development tasks that might exist on existing legacy systems, and they can free up their software engineering teams to do more relevant, interesting, high-level innovation and R&D work, all of which becomes possible when you are using spec-driven development or AI-native development to create velocity inside your organizations. A lot of that means that organizations can stop thinking about legacy code as a cost center that they have to maintain and really start thinking of it as an opportunity space where they can understand what they've got, identify overlaps, intersections, and opportunities to improve, and shift much more of the burden of supporting it away from the talent of your organization and into AI agents and intelligence models that can work together to understand how to accelerate and deliver value.
We've seen some real-world impact from using CoreStory. Can you share some details about the NTT Data partnership and what it means to work with 11 million plus lines of code and their use of CoreStory?
So we've been excited to team up with top system integrators like NTT Data to accelerate their ability to support very large existing enterprise systems, as well as to enhance their ability to maintain and deliver value for their end customers using AI tools. Inside NTT Data, we've been excited to team up with the organization to support a very large enterprise COBOL application running on the mainframe. This application supports huge volumes of daily transactions on real-world production needs. Of course, the way that this was historically handled was by purely teams of humans who would go through, every time a maintenance request came in, a very large code base to try to make changes and hope that these changes did not break. With the use of CoreStory, of course, they were able to construct an intelligence model, a knowledge graph, and a specification describing the behaviors of that code base, which allowed their human beings to make use of AI to understand existing code, to field tickets coming in, and to see a substantial acceleration in their ability to deliver tickets for their end users by something like a 2x gain. Of course, that partnership has proven to be a strong one for a number of customers within both sectors, our side and theirs. We're excited to see how this will roll out as we pick up increasing numbers of maintenance activities within NTT Data's customer base, and we see how the same technology can be used to accelerate delivering value for end customers who are trying to understand their own large legacy code bases and figuring out how to make those systems generate more value at the end of the day.
Discovering business logic and technical insights is a lot of core story. What are some of the more surprising use cases that are not as obvious as modernization or maintenance?
So when everyone thinks about legacy code and AI, they always wonder about how do you extract business logic, how do you understand the architectures, how do I compare what I've got to see what is redundant. There's lots of use cases that go beyond modernization that we have seen people use CoreStory for successfully in the enterprise. I'll give you three interesting examples. The first is inside private equity groups. There is often a frequent need to understand recently inherited code very quickly, typically as part of a diligence cycle, both to understand security deficits, behavioral gaps, whether the value proposition of the code is really what is purported by the team that's coming in. Of course, historically, that's been done by hired gun consultants or very expensive CIOs and CTOs stepping in on short notice, which means that you end up with a potential risk factor. We've seen PE teams effectively use CoreStory to analyze what they've got very quickly and really ask intelligent conversational questions about the security posture of the application, potential IP risks or overlaps, redundancies where they could identify cost efficiencies inside the systems, and understanding how those systems differ from what was being reported out during the M&A process, all of which leads to immediate value for that organization. The second use case we see quite frequently is one where people are asking non-obvious questions about code bases, sometimes to understand things that cannot be discovered efficiently or effectively using coding agents on their own. For example, we had a customer who is a wide user of some of the major popular coding agents in IDEs, GitHub Copilot and Cursor, who was struggling to understand specific behavioral patterns inside their code that were not being found by either of the existing coding agents. Those systems were able to be understood properly by CoreStory because of the intelligence model's ability to describe behaviors of the code in ways that differ from just looking at the day-to-day interactions between each line of code. A third use case that we see that's growing increasingly popular is agent boosting, using CoreStory in combination with an existing coding agent to gain accelerated performance. Often these customers come to us and say something like, we made a big investment in GitHub Copilot, or a big investment in Claude, or a big investment in Codex. And we love these tools, we believe in the vision. They are just not past the level of a smart intern yet. We need to figure out how we can make them perform like a senior engineer. And the answer is, well, give it a spec using CoreStory, let it talk to the intelligence model, and watch what the system is able to do. And consistently, those customers see that each of those coding agents is able to carry out more complicated tasks more efficiently, save tokens, and deliver better results while doing so.
And what advice would you give CTOs or engineering leaders who are just starting to explore AI-assisted development?
If you're an AI leader or a CTO just starting to explore AI-driven development, first, I'm excited for you because of the real upside you are about to experience and the real joy that you will probably get from seeing how much fun it is to build using AI. And for the velocity gain that you can get. It's a remarkable shift in how quickly and how efficiently we're able to go from a slow-moving backlog into a empowered and very active set of developers. And this is a really consistent experience that I have seen both in our own organization and in customer organizations as they adopt AI-native engineering and spec-driven development practices, is that building gets fun again, which is really why we all love technology so much. Now, practically, what are the right ways to do this? There are right ways and wrong ways to implement these solutions. I think one of the things that's important to understand is that AI is not a replacement for human beings in your organization. It is a shift in what those human beings are going to do, and that shift takes some work. In particular, you have to make sure that folks understand that their responsibility is no longer to sit and write code for every single ticket, but rather to supervise the outcomes of a team of agents that are carrying out work. Second, it's also important to make sure that you are not expecting magic without the actual work of implementation and refinement. Sometimes people think that you can one-shot a lot of activities, meaning carry them out without any kind of iteration or feedback. And consistently, we see that successful implementations of AI-driven development and spec-driven development focus on repeated feedback cycles to harden the process and really make sure that it is consistently delivering as expected, which takes a process of a few cycles, a few days, a few weeks to really nail down and get right. Finally, of course, I always recommend that people do think through what their spec-driven strategy looks like and make sure they are following best practices in spec-driven development, meaning do make use of an intelligence model, not just a coding agent. Do make sure that all applications have an attached spec, and do make sure that there is a practice set in place for keeping that spec and intelligence model continuously up to date as you develop. With those three practices in place, you're likely to have a successful run in rolling out spec-driven development and AI native engineering. And you should be able to get a massive increase in your velocity. It's not always the case that technology can deliver on the promises that it makes to an industry. And I think AI is one of the tools that so far has really been able to do so, if you do it right.
So what's next for CoreStory? Any exciting developments you'd like to share?
CoreStory, of course, we were excited to announce our Series A last year. We are about to announce a really exciting set of partnerships with a number of coding agents. You can follow along on our press to see all of that happening. CoreStory is also excited to be able to announce and release a number of new self-serve flows that allow teams inside most organizations to pick up and adopt CoreStory directly on their own and start to implement them very quickly in their own organizations. We're excited for our own roadmap of what becomes possible when more teams are using CoreStory. In particular, we continuously evolve the landscape of what systems we interact with, what kinds of tools we're able to make use of, and how well we're able to understand different kinds of enterprise systems that we encounter. We're excited to continue to support growing numbers of teams as they start to enter their spec-driven development journey. And of course, we're excited to reach out to more and more developers who are able to make use of CoreStory with their favorite coding agents to carry out development in a better way.